Hi, I'm Dr. Swanson and I am the psychologist on the child team, and this is your course on understanding neurodiversity. Now, we're going to start off with just a quick definition of what neurodiversity means. Now, this is a neuron inside our brain, and our brain controls everything that we do or everything that we think, how we learn and essentially how we remember. We use a process of chemical and electrical signals to pass the information from our brain out to our body and then back again. Now, it does get rather complicated and we're not biologists, but the neuroscience is important when we are talking about neurodiversity. So within this lecture, we're talking about neuro meaning our nervous system, how our brain controls what we think, how we learn and how we remember. And then diversity is how we differ. Now, of course, we have neurotypical children, and these are individuals whose brains all work in a very similar way. Now, what I'm fascinated, and I think you are because you're watching this, is by those whose brains function in a slightly different way. And from my perspective, this is not always a negative thing. And at Child, we always think of neurodiversity as a strength-based model and how we can support these children in their strengths and not always look at the negative side of things. But neurodiversity means we get to see the world from a different perspective, and this in many ways could really be thought of as a competitive advantage. Now, neurodiversity is an approach to learning and disability that states that differences are absolutely and utterly normal, rather than brain differences being deficits. And this concept of normality provides us with the space to look for strengths rather than just the negative connotations associated these differences. And it was Judy Singer, who was actually a sociologist, who first termed the phrase neurodiversity way back in the late 1990s. Now, when we talk about neurodiversity, we're including all brain-based disorders, including attention deficit hyperactivity disorder, autism, specific learning disorders, intellectual disabilities. We're talking about communication disorders, motor disorders, but even newer concepts like slow processing speed and sensory processing issues, or even twice as exceptional children. For children with learning and thinking differences, this idea of neurodiversity can have real benefits. It can help children and also parents frame their challenges as differences rather than deficits. And when we look at understanding and assessing children with neurodiversity, we can also approach this from the strength-based model, which is what we try and do at Child. So the Diagnostic and Statistical Manual of Mental Disorders is now in its 5th edition. It was revised in 2013, but it is due for an update, and let's hope this happens within the next 5 years, because it defines and it classifies mental disorders in order for us to improve our diagnosis, our treatment and our research. Now, sometimes it's very easy for clinicians to look at the reliability and the validity of the way in which we are assessing and categorising individuals, but sometimes from a parent's perspective and within the classroom, we see that there are some controversies, but also some differences as well. And at Child, we like to talk these through and sit with parents, sit with children, sit with teachers, and really build a team around the child to really understand that child and what help they particularly need. Now, the DSM update, whenever this may be, and hopefully it will include some new categories. Now, I'm seeing far more children, for example, with processing speed issues, among other differences, that school and parents don't necessarily recognise at the moment, but are requiring specialist support and interventions. So hopefully these will be added, but we need enough research and individuals like ourselves, teachers, parents, as well as clinicians working in the area, to do the research to warrant including these diagnoses in the DSM. Now, when we look at the DSM specifically, we're talking about the category to do with neurodevelopmental disorders. And there are 6 of them. We're talking about motor, communication, ADHD, specific learning disorders, ASD, and intellectual disabilities. Now, a lot is still unknown about the origins of a lot of these disorders, but I will discuss what we do know as we go through, and essentially Many of these are genetic in nature, and many of these do overlap. Now, this overlap is called a comorbidity. So you can be diagnosed with, for example, ADHD and also ASD. You can have ASD and an intellectual disability. Now, I'll talk a lot more about this as we can continue through, but recent research suggests that there is a high positive correlation when we're talking about autism with the age of a father's sperm and the age of a mother's egg. The older the sperm, the younger the egg, the more mutations we are likely to see. And when we're looking at female ADHD, we know it is all genetic. Now, this doesn't mean to say that it passes down in families. In 50% of cases it does, both male and female. But when we're talking about females, we're talking about a lot of gene mutations. But as with all neurodevelopmental disorders, the onset is before the age of 18 and it will run throughout the individual's lifetime. These are brain-based disorders. And these brain differences can affect a person's emotions, their memory, their ability to learn, to socialise, and to maintain their self-control. So let's start off with a little look at ADHD. Now, the term ADHD refers to attention deficit hyperactivity disorder. It is a condition that makes it difficult for children to pay attention and or control their behaviour. Now, interestingly, it is the most common of all neurodevelopmental disorders, and the main symptoms, think of them as typical behaviours, are inattention, hyperactivity and impulsivity. Now, there are 3 presentation types, so you can be diagnosed with a combined type, and this is obviously all of them: inattentiveness, hyperactivity and impulsivity. And from the research, this is the most common presentation. However, I think clinicians would disagree with that and say that actually inattention is one of the most common diagnoses and what we're seeing. So if you think of the combined type, think of Tigger from Winnie the Pooh. If you think of the inattention type, think of Pooh from Winnie the Pooh. And obviously we can be diagnosed with our third type, hyperactivity and impulsivity, without the inattention. And this can be thought of as Rabbit from Winnie the Pooh. They are excessive, these behaviours are long-term, and they occur in all situations that affect these children. So when we are looking at research and trying to diagnose within child, I will be sending questionnaires to parents and questionnaires to teachers, and also looking at the child when we're in the testing environment, and we've got to see those behaviours in every single situation. Now, ADHD is a brain-based disorder. It is related to sustained attention towards a future goal. The area of brain deficit is the prefrontal cortex, which is the front part of the brain, and I'll show you a picture of this in a minute. The prefrontal cortex deals with our executive functioning, and executive functioning is a hot word at the moment. Everyone's talking about it. Essentially, executive functioning is how we regulate ourselves. Now, executive functioning in children in ADHD children runs typically about 30% behind your neurotypical children. Executive functionings are things that you do to yourself in order to change your future behaviour. And this is why ADHD is a disorder of self-regulation. Now, self-regulation is not learnt. Of course, it is a brain-based disorder. Children with ADHD have no voice in the back of their heads assessing if they should or should not do something. Children with ADHD take the most risks. They make snap decisions with no thought to the consequences. They have no inhibitions, and they absolutely lack emotional self-regulation. And if we look at research, particularly in America, female ADHD is the greatest predictor of teenage pregnancy. Now, if we look at management of ADHD, we can see externalising self-regulation using behavioural techniques, and this needs to be done constantly, all the time, in every situation. And if we just skip down one, it's rewards, 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 points, tokens and money. A bit like a diabetic needing insulin every day, these children need behavioural reward techniques every day. Somebody in a wheelchair will always need a ramp to get into a building. You take the ramp away, they won't be able to get into a building. If children don't have behavioural techniques, and externalizing that self-regulation, they will not function. So it is all about rewards, rewards, rewards. And this is because their brain is running their prefrontal cortex about 30% behind other neurotypical children. So if you've got a child and you teach a year 6 class, treat them like a year 3. If you've got a year 3 class, you've got a child with ADHD, treat them like a year 1. Always think 30% behind. Now we know about working memory deficits. These children have working memory issues, and working memory is part of one of our executive functionings. So we need to externalize our working memory and break things down. ADHD is a disorder of time. They have no internal time. So giving a child extra time on a test is painful. What you need to do is give them the same amount of time, but just, give them breaks. And these children will need timers, stopwatches, constantly reminding of what to do and when to do it. Now, our executive functioning, our prefrontal cortex, is a fueled engine. It does need some sugar or something to help us function. So if they are doing A-levels or IBDP, whatever it happens to be, in a really strong or GCSEs work environment, then they will need to just sip on a little bit of lemonade or something to keep their brain fueled. Now, interestingly, there is some wonderful research now on medication and mindfulness. Both work well. What works better is when they're both used in combination. However, there are a lot of medications on the market now, stimulants and non-stimulants. You need to find out what works for that particular children. And now there is slow release, the Concertas, the Adderalls, the Ritalins and the slow release Ritalins, all sorts of different things. They do work nearly 90% of children. So mindfulness does work, and there's some great research there as well. It will all depend on the family, depending on what route they go down, but the combination of both medication and mindfulness is definitely the best that we've seen in research. And also think about the comorbidities. These children, 50% of children with ADHD will have anxiety. A lot of these children will have specific learning disorders. A vast majority of children will have oppositional defiant disorder, and if that isn't treated, that goes on to be in sort of later adolescence and on into adulthood. We see the conduct disorders, the actual wanting to control people, to control the situation, and as I said, the anxiety, but also some depression. Now let's move on to ASD. Now, autism is a spectrum disorder rather than a syndrome, which means that each and every child with autism is different. It is genetic in that we know there are about 200 to 400 gene mutations, but there are also de novo cases, which means there are new cases. We know that in identical twins, 77% is likely in the concordance rates, as well as siblings, it's about 20%. We do know that the age of the egg and the sperm make a huge difference in the gene mutations, and there's some great research on that. The younger the egg, the younger the sperm, etc., will make a difference to the gene mutations. We thought that more males were affected, and this was thought to be due to the sort of the protective factors of hormones in females, the love hormone oxytocin. Yet in recent research, we're understanding that girls with ASD, and we are recognising more and more of them, just have a very different presentation in girls, and I'll talk a little bit about that in a minute. Misconception of vaccines: they do not cause autism. Full stop, rule off. Now, we know that during pregnancy, exposure to certain things may lead to autism, especially medications, for example, serotonin reuptake inhibitors. We know that certain epilepsy drugs, we know that rubella during pregnancy, we know that the cytomegalovirus, and even the gap between births. If there is less than a year between babies, mothers are still getting sort of over the first pregnancy and birth, and levels of vitamin B and iron aren't quite back to normal, and we know that has an influence. So there are a huge environmental factors to do with autism as well. Now, all children with ASD will present with the umbrellas SC, social and communication deficits, and also RRBs, restrictive and repetitive behaviours. Now, these are behaviours associated with autism spectrum disorder. Now, again, each and every one of the children you will see will be different in the way in which they behave and what you will see. However, they will all come under this umbrella. Now, females do present in a slightly different way. They are far more sociable creatures, so you see fewer of the typical social communication deficits. However, they are still there, but you also see fewer of the restricted and repetitive behaviours in an obvious manner, but they will still be there. Now, restrictive and repetitive behaviours are thought to be calming. We all develop ways to deal with our stress, don't we? We all bite our fingernails, we all chew our lips. Children with autism also do this. They have high levels of anxiety, and we think that these RRBs are there just to reduce that type of anxiety. So it might be that you're seeing this in the classroom. What you need to do is make it work for you. Whatever it is in that classroom, the restrictive and repetitive behaviours, just change it. Try and do something that is obviously less intrusive into the classroom. Repetitive behaviours that you might be seeing are those spinning, the twirling, the rocking, the flapping, but it could also be very subtle, but it could also be speech. So it could be repetitive speech and they just say the same kind of things over and over again. The inflexibility could be the rigidity. They want the same things, they want to wear the same clothes, they want to eat the same food. It could be inflexibility and rigidity in thinking, and the inflexibility here can also be demonstrated in a robot voice. We can have restrictive interests, fixed interests, a focus, and also this is where we see the girls are slightly different. We see fewer of these restrictive behaviours, but they can be very subtle. So it could be a real fascination with unicorns, but it could be a particular area of unicorns. We could see a fascination with horses, but it could be a particular area. So it's not that we're not seeing these behaviours, they're very subtle, and you've got to really know that child to say, oh, that's slightly different from a neurotypical child. They might have a fascination with whatever it is, however, it is far more obsessive than it would be in a particular specific than it would be in a neurotypical. And also we can see sensitivities, the food textures, the smells, the clothes tags, the typical things you might see. With females and males, this reciprocity, this backwards and forwards in conversations, they're not picking up the nuances in conversations, that non-verbal communication, and in relationships they don't particularly want friends or have friends. Within girls, what we see is they're attracted to very strong female personalities because they don't really know how to communicate and understand. We see that they have empathy and they can have empathy for others, but they don't necessarily understand the emotions within themselves. So autism is very complicated in the fact that it is a spectrum disorder and not a syndrome. So what you might see is these children may show restricted areas of interest. This is across the board with children with autism, but particularly girls, they just might be a little bit more what you'd expect to see in a child, in a girl, but just very specific. With boys, you can see that they don't necessarily play with toys in the manner in which they're designed. So, for example, playing with a car, a toy car, they might just spin the wheel all the time rather than playing with the object as it was designed. Again, that is a very typical view, and remember that autism is on a spectrum, so if we're looking at children who are more highly functioning, you don't necessarily see these types of behaviours. Now, what we do see is a disregard for others. Even in high functioning individuals, they've learnt that they have to be sociable, they've learnt that they have to have eye contact, particularly with girls are more social beings anyway. They just do not form the same relationships as you would see in a neurotypical child would. Particularly for females, they might be attracted to those very big personalities. They might not hold on to friendships as well as neurotypical children would. And because they just don't pick up on the nuances and that backwards and forwards conversation, they just don't need that friendship support like other children would. Now, many children with autism, you will have seen a diagnosis already, but a few, particularly those who are high functioning and those who mask their symptoms, are not being picked up. And particularly with females, we're not seeing them being picked up at all, or sometimes they're being misdiagnosed with ADHD. Now, research does indicate that the earlier we start intervention, the better for children who have autism. If we've got tools in their toolbox in order to help them navigate the world, they can interact with it far better, with far fewer anxieties and far fewer repetitive and restrictive behaviours, so that they can just navigate the world in which us neurotypicals live. Now, there is a stigma attached to the diagnosis of autism, and I think particularly now that clinicians have lumped all of the different diagnoses into autism, if you've got a child who is high functioning and still being classed as autistic, as opposed to somebody who has absolutely or is non-verbal and rocks in a corner, it's a very different diagnosis. So just be aware, we are talking about a spectrum of disorders and not a syndrome. I think it's also important to state that don't assume anything about a person with autism. Just because you're having a fluent conversation with somebody, don't think they don't, then understanding everything you're saying. They might not be picking up on a lot of what you're saying. They're certainly not picking up on the non-verbal behaviour. They're taking what you say quite literally, and they won't read between the lines. So just because you're having an eloquent conversation using lots of technical terms and wonderful words and the lexical knowledge is there, they don't necessarily pick up on the majority of that conversation. And just because somebody doesn't acknowledge you when you walk into the room, and maybe they're not toilet trained, again, doesn't mean to say they don't understand everything that you are saying to them. So essentially, don't assume anything about a person with autism. Now we're going to move on to twice as exceptional children. Now, this has been around since the 1970s, and there's been a lot of research on twice as exceptional children since then. It is very difficult to diagnose, and I think as procedures have grown and we have the Whisk and the Wyatt now, we can identify twice as exceptional children far better than we have done previously. These children are identified as gifted, yet they also have some form of learning difference. Now, the only disorder or disability they can't have is that intellectual disability, because to have an intellectual disability you can't be gifted, because you need an IQ of less than 70. Now, when we're looking at gifted children, there's so many different arguments around what is gifted. In some countries it can be seen as elitist, but what we're really saying is it's not just about the concept of IQ anymore. Children can be gifted in many different areas, and in Hong Kong they follow the US definition of gifted and talented, where you can be gifted in a psychomotor skill, you can be gifted in drama, in music, in leadership, as well as more of the traditional concepts of academics. And we're seeing quite a few schools now offering leadership scholarships. So be open-minded about children who have these asynchronicities with their abilities. And that is the key concept here, is this asynchronicity. These children are essentially all over the place in terms of their academic ability or their age-appropriate development. They're just not in sync. And sometimes within the classroom we do see this discrepancy between the potential and the output. And a lot of these children do have problems with behaviour. They have poor self-concept, they have a misdiagnosis, or they are underachieving. And there are a lot of misdiagnoses when it comes to gifted and talented individuals. And we also need to look at the work of Dabrowski and understanding those overexcitabilities in gifted children. A lot of twice as exceptional children have the extreme frustration because they have the ability in one area, yet for argument's sake, they could be dyslexic and really struggle to read. So there are the frustrations there. They could have a lot of low self-esteem issues, and sometimes this gift and the learning disorder, or whatever the disorder happens to be, can lead to socialisation. They don't know where to fit in. Sometimes they're in accelerated maths classes, but in remedial English classes. It's very difficult to know who your friends are and where you fit in. And this can lead to more conflict, to more misunderstanding. And we do see a very high proportion of twice exceptional children failing, because some of them are seen for their ability and not their disability. Some are seen for their disability and not their ability. So it's a very complex and complicated area. There are numerous examples of individuals who have this twice as exceptional ability and go on to do amazing things. Children with autism who have make incredible Lego creations. That person who has ADHD that starts their own company as an entrepreneur. And we can look at Society for that one, and Richard Branson and all sorts of individuals who go on to do amazing things. That child who has dyslexia but is also a master chef in the kitchen. So we need to think about this neurodiversity in some respects as a competitive advantage, but absolutely children who are twice as exceptional need to be understood for this asynchronicity and need to be supported throughout their schooling. Okay, so specific learning disorders within the new version of the DSM-5, this did actually change quite considerably in the fact that you get diagnosed with a specific learning disorder and then you'll have your specific impairment. So it could be an impairment in reading, in maths, or in written expression, and you can have one of these, you can have two, or you can have all three of them. Now they do come under the umbrella of specific learning disorders. All of them are a cluster that affect the acquisition, the organisation and retention of understanding, verbal and also non-verbal information. And they are not due to visual, hearing, autism, intellectual disability, emotional, or they're nothing to do with being disadvantaged as a child. So culture, economic or environment, they are brain-based disorders. Now when we're talking about dyslexia, this is an impairment in reading, and we know children with dyslexia have poor working memories. We know that they have poor processing speed, but these children can actually have great visual spatial awareness. We know that with written expression, we're talking about dysgraphia. They have problems organising and writing the concepts. Trying to get it down on paper is problematic for these children. We also know that sometimes the handwriting can be impaired as well. With dyscalculia, it's that not having a sense and a concept of numbers. With all of them, particularly with maths and reading, we can see that working memory and processing speed is particularly difficult. If you're thinking about writing a sentence for written expression, you've got to hold in mind the capital letter, the full stop, the words you want to use. So with all these specific learning disorders, we are seeing problems with working memory, processing speed, yet these children can have really good visual spatial abilities. So moving on to intellectual disabilities. Now, to be diagnosed with an intellectual disability, you have to have an IQ of below 17, and more recently, we've also brought in this idea that you have to have adaptive functioning deficits. And this essentially, adaptive functioning covers daily living skills, motor skills, communication and socialisation. And you have to have one of these, or more than one, that has a significant impact on that person's life. Now we know that there are around 850 genes that are involved with intellectual disability. Some run in families and some are de novo, some are new. And there are also a number of other reasons why children may develop an intellectual disability. The three most common ones are Down syndrome, Fragile X syndrome and fetal alcohol spectrum disorder. However, don't be masked in the idea that all children with FASD have an intellectual disability. This is just one point of FASD. We know there are so many different presentations. Again, Down syndrome and Fragile X are syndromes, so therefore there are particular genes involved with that, whereas fetal alcohol is a spectrum disorder, so there will be different mutations of genes and different levels of alcohol at different times will influence that brain development. So if we're looking at Intellectual disability, we're looking at pregnancy, it could be drugs, toxins, viruses, rubella, syphilis. If we're looking at genetics, it could be something like Fragile X syndrome, it could be phenylketonuria, it could be a PKU, or it could be a Down syndrome, which is that extra 21st chromosome. PKU is that recessive gene, it's inherited, so the birth mother and father carry the gene, and it's all about build-up of proteins within the body, and this leads to irreversible brain damage. And if we get it early and we understand it and it's tested, then the child can actually be okay if they're put on a very special diet. With Fragile X, we're talking about the X chromosome, and this is mutation of the genes on the X chromosome, and that's why it affects more males than females. Now, we know that there's environmental factors to do with neglect, abuse and malnourishment, and again, the way in which our brain develops those first 100 days are absolutely crucial in the way in which we are forming those neural networks. So anything to do with malnourishment, abuse or neglect can affect the way in which our brain develops. And again, any illnesses in childhood, meningitis, encephalitis, can also influence our brain and how it develops those neuron pathways. Now, diagnosis used to be about 5%, but using modern genetic identification, we can identify about 70% of disorders. So this is really actually positive for the future. We can see the environmental effects, then we can treat them. If we know the genetic predispositions, we can change it or identify them early. So this is actually some great research into understanding, identifying and preventing intellectual disabilities as we move forward. Okay, let's move on to the brain just very quickly. We know that there are 4 lobes of the brain. The frontal lobe, just there, the parietal lobe, the occipital lobe, and the temporal lobe. Now, the frontal lobe houses our motor cortex and is the most advanced part of our brain. It's the largest part of our brain, actually. Our frontal lobe deals with all our complex cognitive processes and also our abstract thoughts. It houses our short-term memory. It plays a role in our personality. And it doesn't actually stop developing until we're in our mid to late 20s. So, for example, 15-year-olds have not yet fully developed the ability to understand the consequences of their actions. And this is why children have difficulty with planning, with organising and learning from their mistakes. Children are impulsive and sometimes they can be inappropriate. They have a roller coaster of emotions, and working towards sort of distant goals rather than being unduly influenced by immediate results is actually a stretch for them. And if we think what we know and learnt about ADHD, ADHD is a performance disorder in the fact that it's all to do with our prefrontal cortex. And if you think about the prefrontal cortex developing about 30% behind neurotypical children, then we start to see how important understanding ADHD is, because the major impairment of the prefrontal cortex stops developing at essentially 25. As an adult with ADHD, you're thinking of behaving like an 18-year-old. So ADHD in adulthood can be immense in the risk-taking and the behaviours. There is no stop and think. There is no thought to the future. And this is why we need to understand ADHD in children and support them, to put a lot of preventative measures in and support in so that their behaviour as adults can be controlled. Now, our frontal cortex also houses our Broca's area, and that is important for language, and I'll come back to that in a minute. Our parietal lobe deals with all our sensory information and also our perceptions. If we think about what we know about ASD, for example, and sensory overload, that sensory processing disorder, it's beginning to make sense why we say these are all brain-based disorders. Our occipital lobe, this lobe at the back, deals with all our vision, our colour recognition and also processing of visual information. And if we think about dyslexia, it plays an important role in how we see words on a page, process them in our occipital lobe, and then process them to our Broca's and our Wernicke's area on the left hand side of our brain. There's a lot of areas and neural networks that have to be connected at the right time and the right speed for us to decode words, and we'll come back to that again in a minute. Our temporal lobe plays a crucial role in processing of sound, and that's easy to remember because it's just above our ear. The temporal lobe also houses our memories. It has our hippocampus, and it's also just behind it is our limbic system that deals with all of our emotions. Now, there are also two special areas just on the left hand side of our brain related to language, and this is Broca, and this is to do with production of language, and Wernicke's, which is to do with our understanding of language. And they are connected and they are interrelated, and they do play a huge role in how we process and understand information. Now, if we look at this slide here, there's a lot to take in. As we said before, our prefrontal cortex, a lot to do with ADHD, and it's to do with our executive functionings. A lot of our executive functionings are in this prefrontal cortex, our working memory, our attention, that shifting of attention. It helps us filter information. It's about our self-control, it's about our motivation, it's about our personality. Our prefrontal cortex does a lot of this higher order thinking, and when we relate it ADHD, we can see why we are talking about a disorder of self-control and that attention to future goals. We also know, if we think about our brain for ADHD, it's not a disorder of knowing, it's a disorder of performance, and this is why it's a disorder of performance, because it's all to do with our executive functions. Our parietal lobe, when we look at ASD, it's all too much. The sensory processing coming in, the touching, the smells, everything that is going on, and we know that has a major role to play in autism and also sensory processing issues. Our occipital lobe, our reading, our spelling, all maps onto our visual system, and again has then to process onto our Broca's area and our language. So our occipital lobe plays a huge role in specific learning disorders. Now, our cerebellum is interesting. It's our little cauliflower at the back of our brain, older than the rest of our brain. And if we've had too much alcohol, this is why we get a bit wobbly, because it does a lot to do with our balance. But it also houses motor skills, language, emotions, executive functionings. And in ASD, it's slightly larger than typical developing children. There's a lot of research done on that. Our temporal lobe, again, to do with ASD and specific learning disorders, understanding language, reading facial expressions, all that kind of thing. Our limbic system is our emotional centre of the brain. And again, if we look at ADHD, the anxiety, the aggression, the ASD, anxiety, aggression, the eye contact, all comes from our limbic system. So we do know that our brain plays this major role in the development of brain-based disorders and neurodevelopmental disorders. And even things that aren't in the DSM, so processing speed, how we get information from our working memory to our long-term memory and from our long-term memory back out again. And we know that processing speed can be a predictor of things like dyslexia. So we do look at that when we are testing within our IQ tests and cognitive functioning tests. But at Child, we always want to end with some strengths. These children will have challenges, we know that, but some children with neurodiversities are the most practical, they are the most resourceful, they persevere, they are global thinkers, they connect ideas that other children don't. Now, sometimes in a classroom this is very difficult for them, and you can see the attention, the spelling, the social skills, the processing can be very problematic, but in the real world they can excel if we are giving them the tools and the support in order to understand their neurodiversity. Some of these children have amazing long-term memories, they have good visual spatial skills, they have good oral communication. So instead of changing the child, we need to change our viewpoint, the way in which we see the world, in order to help them and support them as they go through the educational journey, because that can be a very tricky time for a child who has severe neurodiversities.